Good day everyone. In this video we are going to learn about exponential function and logarithmic function. So we have a short explanation so that you will understand what is all about exponential function, and we have the logarithmic function. So exponential function can be defined as f of x, or function of x, is equals to b raised to the power of x, where b is the base and x is the exponent. So the domain of this one, or the values of x of the function, is all set of real numbers, meaning real numbers is from negative infinity, negative value of x, up to positive infinity, or positive values of x. So let's try some examples with the base 2. So for example, we have f of x. The function is f of x is equals to 2 to the power of x. So what if the values of x is equals to 3? So the function is 3. So you will have now 2 to the power of 3, which is 2 cubed. So you will multiply 2 times 2 times 2, we will get 8. What about if the function is 3 over 2? So therefore you will have now as 2 to the power of 3 over 2, or you can factor this one out with the rule of loss of exponent, which is a to the power of m. If whatever the exponent it is, if you are going to multiply, you are going to add the exponent. So therefore we have 1 plus 1 over 2, that is equals to 3 over 2. And then 2 to the power of 1 over 2 is also equals to 2 square root of 2. So therefore you have this answer. So f is 0, or the function is 0. So whatever value raised to 0 is always equals to 1. Let's review some of the laws of exponent. So let a and b be positive numbers, and let x and y be real numbers. So here we have rule number 1, or the property of the laws of exponent number 1. So we have bx, as what I've said, b to the power of x times b to the power of y. We will have now as bx plus y. Second one, bx over by is equals to bx minus y. Third one, b to the power of x, open and close parenthesis y. So you will have to multiply now the exponent. So therefore you will have bxy. Then we have the properties of, we have exponent as well. We're going to distribute all the values of x. So you will have now a to the power of x, b to the power of x. And then we have as well the quotient property. So you will have to distribute again from the denominator up to numerator. So you will have a to the power of x and b to the power of x. So these are the properties that you need to remember when you're going to solve exponential function. Okay, let's try some examples. We have to find the function f of x is equals to 2 to the power of 2x minus 5, and find the value of x, for which f of x is equals to 16. So therefore you have 2 to the power of 2x minus 1 equals to 16. We will try to make the base the same so that we can solve for the exponent. So therefore the factor of 16 is 2 times 2 times 2 times 2, which is 2 to the power of 4. This is also equals to 16. So therefore now we can solve for the exponent. We will have 2x minus 1 equals to 4. And then we can have now as x equals to 5 over 2. What is the graph of exponential function f of x is equals to 2 to the power of x? So let's try to make a table. So let's just go directly to the table for this one. Okay, so these are the table of x and y values. So therefore, if you have the table, you can already plot the graph easily, right? If the x is negative 5, 1 over 32. If the x is negative 4, 1 over 16. So you just only substitute the value of x into the function f of x, which is 2 to the power of negative 5, which is the negative 5. You're going to inverse, which is 1 over, okay, so it will make you 1 over 2 to the power of 5, which is 1 over 32. And you're going to go to the positive. We have values of x, so any variable raised to 0 is equals to 1. 2 to the power of 1 is 2, 2 squared is 4, 2 cubed is 8, 2 to the power of 4 is 16, and 2 to the power of 5 is, we have 1 over 32. So if it is negative, you're going to make it as a fraction form. So therefore, the graph now, okay, so let's have to go directly to the graph. So the graph is equals to f of x equals to 2 to the power of x, which is from negative infinity, negative value of x, going to positive infinity, is increasing. Okay, so then let's try some examples. Another example, let's say we have a fraction form, which is 1 over 2x. And then let's try to get the values of x. So we have the opposite way, the opposite values of the original function, which is 2 to the power of x. So we have now negative 5, which is 32. Okay, so you can observe that the function of 1 over 2x is a reflection, okay, of f of x is equals to, we have 2x. Okay, so because of the values here, we have 1 over 2, 2 to the power of 1 over 4, 3, 1 over 8, 4, 1 over 16, because you're going to have 1, and then we have 1 half squared. So therefore 1 half times 1 half, 1 half times 1 half times 1 half. So you are just going to multiply the denominator. So therefore you have these values. So what is the graph now? So we just compare the two graphs. So this is the graph of exponential function, which is f of x is equals to 1 over 2x. Okay, 1 over 2x, and then the other one is f of x is equals to 2 to the power of x.